Hi, my name is Steve Matthews, and today I'd like to talk about gravity and the curvature or the supposed curvature of our Earth. We are told that gravity holds the waters of our oceans down to the Earth. And we are also told that gravity holds that same water suspended in an arc. Let's consider a little experiment here. If we had a football field approximately 300 feet long, uh, you would have, according to the curvature calculator, you would have water 3.78 inches at one end of that football field. It would taper up from one end, from nothing, right up to the other end to 3.78 inches. That's just one 300-foot football field. Now, everybody tell me what would happen to that water. Would it stay there? Or would it collapse? Well, we all know what it would do. It would collapse. Okay, so let's consider something a little bit larger. So on your screen, I went out and took a picture, a little video actually, of the Pacific Ocean. Right now you're looking off to the southwest from Coos Bay, Oregon, and I'm at Cape Argo. It used to be a lookout station. I'm looking out toward Honolulu, and past that is Australia. Honolulu is 2,456 miles. Australia is 7,531 miles. Now, if we just went as far as Honolulu, the curvature of that water, that ocean that you're looking at there, would reach a height of 737, not feet, miles. So now we've compounded our problem. Remember our football field with 3.78 inches at one end? Well, we all know that would collapse. Well, the same force that they say holds that water up in the air is actually the same force that's going to bring it down. They can't have it both ways. I know they want it both ways, but it doesn't work like that, and we all know it. You aren't going to have a 737 mile high arch of water without some disastrous consequences. And I mean, I hate to break that news to anybody, but that's just the way it is. No, our oceans are just as they appear. They're quite flat. Now, it doesn't really matter for this video if that force is gravity or if the force is buoyancy and density. The water is not going to stay up in an arch either way.
Yeah.
Now I've put together a couple more little demonstrations of some above ground swimming pools that people have collapsed. And so you can see what the effects are when you have water stacked in a pile. Liquid water does not stay in an arch. It will seek level every time. Now, after the pool demonstrations, I've taken a clip of the earthquake that happened in Japan. Now, that was not vertical movement of the earth. That was horizontal movement. And with just, I think it was 164 feet, something like that, of movement, you saw on television, all of you have, the devastation that caused. Now that's what happens when you displace water, even just a little bit. So you can see our problem of a 7-mile high wall of water. It just gets compounded worse and worse and worse. Now, after the clips on the Japanese earthquake and the tsunami that preceded after that, I will show you what's going to happen with that 7-mile high wall of water. So enjoy the rest of the video, and thanks for listening. I think you see what I'm talking about. As you think about these things, I'd like you to also consider that water, the weight of it, it's at 8.35 pounds per gallon. Now that's 41 pounds for every 5 gallons. It gets extremely heavy. So the force, the magical force that they say suspends it, it has to get pretty powerful because those oceans are mighty big. And we're talking a lot of weight and a lot of water. And just another consideration. For those of you that are going to insist that, yes, water can be stacked in 3 or 4 inches high and not collapse, and or 7 miles high, well, I'll tell you, if you believe that, flat earth is going to be a piece of cake to believe. I say this because you're not going to have to escape reality to believe flat earth.
Diagonal. I didn't go nowhere.堤防を越えるかもしれない。
So we've seen what happens when you displace 3 feet of water. Now let's see what happens when you displace a mile-high arch of water.
I didn't go nowhere.
In recap, what we've covered is that in 300 feet, you would have 3.78 inches of water arched at one end. And we all know that would not stay in its place, as we're told. They tell us that gravity holds water down, but yet it also suspends water in the air. They can't have it both ways. Also, what we covered was the distance from Coos Bay, Oregon, on the west coast of the United States, to Honolulu is 2,456 miles. The arc of water at its crest would be 737 miles, not feet. And we all know that would not stay in its place either. So it's kind of a ludicrous formula that they use to achieve all of that.